question number 9. A 0.0560 gram of acetic acid is dissolved in enough water to make 50 ml of solution. Calculate the concentration of acetic acid at equilibrium given that the Ka for acetic acid is 1.8 times 10 to the power of negative 5. So, definitely this is an acid and base question. So how are you going to tackle this kind of problem is that when you have this, the value of mass, so if you have the mass, what you can calculate is the number of mole. So number of mole is equivalent to mass over R and M. So the mass is 0.0560 and the RMM is, because it's CH3COOH, so carbon is 12 plus hydrogen is 1 times 3 plus another carbon 12 plus 2 times 16 plus another hydrogen, just 1. So you will get 0.0560 over 60 and you will get the number of mole is 9.3333 times 10 to the power of negative 4 grams per mole. Okay. If you can remember, when you want to do an ice diagram, what you really need to calculate is the molarity, because in ice diagram we are looking at the molarity instead of the number of mole. So referring to the question again, state that it dissolved in enough water to make 50 ml. So from here we can calculate the molarity. Molarity is number of mole over liter. So here, alright, we're going to calculate the molarity equivalent to mole over liter. So the number of mole is here, the one that we have calculated before, 9.3333 times 10 to the power of negative 4. Given in the question, it is being added to enough water to make 50 ml. So 50 milliliter, you want to convert it to liter, divided by 1000. After the calculation, you should get the molarity equivalent to 0.0187 mole. Okay, now after calculation of the molarity, we can now do the ice diagram. So before that, we need to do the dissociation of the acetic acid. So acetic acid, CH3COOH, it will dissociate with, because it add water to it. So CH3COO minus plus H3O plus. So remember, in ice diagram, the addition of water is not play a role in the ice diagram. So that's why I put it just here. So your ice diagram, I, C, E. So initially, the concentration is 0.0187. The molarity that we have just calculated, 0.0187. So at first, there's no dissociation occurs, so 0, 0. So change negative X, positive X, positive X. And at the equilibrium, you will get 0.0187 minus X, and this one is X and X. Given in the question is the value of Ka for the acetic acid, which is 1.8 times 10 to the power of negative 5. So we can do Ka equivalent to X times X divided by 0.0187 minus X. So your X is from the question, which is 1.8 times 10 to the power of negative 5, equivalent to X squared divided by 0.0187 minus X.
So what we need to do now is find the value of x. So it's easier for us to approximate. So what I do is I just remove this x, remove it out. So you will get 1.8 times 10 to the power of negative 5 is equivalent to x squared divided by 0.0187. So it's easier for you to get the value of x, where from this calculation you get x squared is equivalent to 3.348 times 10 to the power of negative 7. Therefore your x is the square root of this one, so be 5.7862 times 10 to the power of negative 4. So this is your value of x. But since we approximate the value of x here, we already deducted all these things, so we need to check the validity of this x. So how are we going to do that is that we take the value of x, is the value of x divided by initial concentration times 100%. And this value, please remember this formula, and this value should not exceed 5%. Then only we consider that this x is valid. Okay, your test is equivalent to your x, 5.7862 times 10 to the power of negative 4 divided by the initial concentration. From your ice diagram you can see initial concentration is 0.0187 times 100%. So you can calculate those and you will get equivalent to 3.0942%. So since this is less than 5%, therefore this value of x is approved. Okay, so next the question asks you what is the concentration of CH3COOH at equilibrium. So we look back at this ice diagram. So it wants you to calculate the concentration of acetic acid at equilibrium. So acetic acid at equilibrium. So at equilibrium, the concentration of acetic acid is equivalent to 0.0187 minus x, where your x is equivalent to 5.7862 times 10 to the power of negative 4. So you will get the value of concentration of CH3COOH, your acetic acid, equivalent to 0.0180 molar.